for the differential equation dy dx equals negative x over y at 1, 1. Negative 1. Yep. You just plug the point into the right-hand side of the differential equation. True or false? Dy dt is equal to just a function of t's, and dy dt equal to just some stuff with y's. Are both of those equations separable? Yes. And multiple choice. A slope field is an example of a qualitative, analytic, or quantitative method. Qualitative, yeah. Okay, so remember that the geometric interpretation of a derivative, dy dt, is that it's the slope of a tangent line, right? So derivative is the slope of a tangent line that's tangent to the curve y of t. So the right-hand side of the differential equation, whatever's over there, it's a function of t's and y's. There are t's and y's over there. Okay, whatever. dy dt yields the slope of the tangents at various points on the graph of y of t. So you can get a rough idea of what the graphs of the solutions look like by sketching a slope field. So you select points in the ty plane and you compute dy dt at each of these points. And then at each point you draw a little mini tangent line. And once you have a lot of mini tangent lines, you start to get a qualitative picture of what the solutions look like. So if I was going to sketch a slope field for dy dt equals y minus t, I can just make a little table over here. You just pick random points, and I just picked like some integer points near the origin. So for 0, 0, you plug 0 in for y, 0 in for t, you get 0. Right? Take 1, 0, plug 0 in for y, 1 in for t, and you get negative 1. If I were to do, say, 1, 1, dy dt would be 0. 1 minus 1 would be 0. 0, 1 would be what? One. Y minus t, right? The y coordinate is 1 and the t coordinate is 0. Negative 1, 0. So that would be 0 minus negative 1, which is 1. What else haven't I done? 0, negative 1. That would be negative 1 minus 0, which is negative 1. 0, 1. 1 minus 0. Oh, I already did that one. Yeah. 1, 2, 3, 4, and the origin. And then 5, 6, 7, 8 would be the corners. Negative 1, 1. 1 minus negative 1 is 2. Negative 1, negative 1. 0. One, negative 1. So that would be negative 1 minus 1, which is negative 2. So I have slopes of all these little mini tangent lines, and now I can just sort of draw them on the graph. So at 0, 0, I have a 0 tangent line, which means flat. Right? Just draw a little tiny tangent line. At 1, 0, it's negative 1, so it looks something like that. 1, 1, I've got a flat tangent line. 0, 1, tangent line of 1. Negative 1, 0, tangent line of 1. 0, negative 1, tangent line of 1. Negative 1, 1, negative 1, 1, I've got a tangent line of 2, so it's a little bit steeper. -1, -1 is flat. And 1, -1 is steeper but negative. So this is the beginnings of a slope field. Okay. It takes a lot of mini tangent lines to get an idea of what the solutions look like. This is very tedious to do by hand and inaccurate, right? Because it's really hard to tell the difference between a slope of 1 and a slope of 2 and a slope of 3 and a slope of 5, right? So a computer is way better at doing this than we are. So I will rarely ask you to do this by hand. Like on a quiz, I might ask you to do 3 or 4 points just to show me you know what a slope field is. But in general, a computer is a much better tool for creating a slope field than drawing it. So your graphing calculator can create a slope field. You have to download a special program, and I've given instructions on how to get it later in the packet. So that's your 83. Your 89 can do it innately. It's built with a slope field. Or you can use a free graphing software like GeoGebra. Yeah, you need the program. Yeah, 83s and 84s. You have to download a program. So here's a more detailed slope field for dy dt equals y minus t. This is the one that we had just started drawing, and we had put in 8 points. Right, so that's what it looks like. So you can start to get an idea of what these things look like by choosing an initial value and trying to follow the slope field. So you imagine that you're driving a car in a parking lot, and you have to follow the lines of the parking lot. Like it's kind of the lines on the ground just direct you which direction to go. So if you start somewhere, like let's say I start right here at the origin, if that was my initial value, I just have to kind of try to follow the slope fields, and it looks like I kind of go like this. Over there and over here, maybe something like that. And this is very qualitative, right? It's really hard to get an accurate picture of exactly what the x and y values are, but you can see the overall shape of the graph. Okay, so here are a few solutions that correspond to different initial values. Because remember, there are an infinite number of solutions to the differential equation, all depending on what the initial value is. So I've got 5 different initial values plotted out there. So technology you can use to create a slope field. There's a link here, which would be live if you went to this packet in Moodle, where you can download a program. You can do it in a TI-89, and there's directions here on how to do it. And then you can also create one in GeoGebra, and I gave directions on how to use GeoGebra to do it. Extra what? Oh, I don't know. I'll look around. Yeah, I'll look around. No, I will not ever ask you to create a slope field on a quiz or a test. You might want to make one while you're working on a homework problem, something like that, to confirm an analytic solution that you came up with. You might create a slope field and just say, oh yeah, my analytic solution matches that picture. So this is something you might want to use for homework. If I wanted to do something with a slope field on a quiz or a test, I would just give you the slope field that I created using technology, ask you questions about it, ask you to calculate maybe the slope of one mini tangent line, or matching, give you a differential equation and have you choose the correct slope field. So you wouldn't have to create one using technology. All right, so that's basically it about slope fields. Plug in points, get slopes and mini tangent lines. I'm going to have you do some activities now. This first problem goes back to that sugar vat mixture problem that we did last class.